Big dreams are what allow us to explore the unknown and push boundaries. The Re3D team is made up of dreamers and doers, EXA engineers, and contractors. Inspired by our travels with Engineers Without Borders, NASA JSC in 2012, we shared a big dream. We were going to launch the world's first affordable, open-source, large-scale 3D printer that our friends in resource-constrained areas could use to make local goods from plastic waste. And so we did. After becoming a finalist in the Instructable's Independence Project for a toilet-sized 3D printer that could accept recycled filament, and the support of startup Chile, we launched on Kickstarter in 2013 at South by Southwest. Gigabot was born. And as Gigabot grew bigger, so did we. We began doing applied research at our outpost in Puerto Rico with the support from Parallel 18 and upgraded our factory space when we purchased a building in 6 acres in Austin, thanks to global sales and pitch competition earnings. We also began tackling another big dream, modifying Gigabot to print with recycled plastic flake. Thanks to a Phase 2 NSF SIBR, GigaBotX became the Re3D's first pellet printer, enabling printing using pellet and flake plastic, as well as an NSF Convergence Award to print from waste in a shipping container with the Austin Habitat for Humanity Restore. Due to our passion for both space and waste, we were honored to be finalists at the CES NASA iTech competition, where we shared a vision to use waste from center operations in GigaBotX. The feedback from the CTOs was positive, but they encouraged Re3D to think about how to print from waste in space. This feedback inspired Re3D to apply to the NASA Ignite opportunity, where we were funded to produce a prototype of a low swap system to print with an analog to space phone.
During Ignite Phase 1 and Phase 2, we learned a lot about working with low size, weight, and power constraints and how to work with very low density materials like shredded foams and shredded films, especially when dealing with microgravity and the challenges therein.
The LunaRecycle Challenge inspired us to pull together teammates with expertise in 3D printing from waste to create a new printer system. Our team includes Chris, who leads our engineering efforts to print with granulated PP and PE waste, Patrick, who has experience using nylon and PE film shreds as 3D printing feedstock, Eric, who is currently designing a very large-scale 3D printer to accept commingled plastic waste and wood pulp, Mitchell, who leads software and engineering controls efforts through custom machine solutions, and myself, Samantha, a former NASA contractor, twice rejected astronaut applicant, and the PI on our NSF GigaBotX printer contract.
The LunaBotXS system is being designed with lunar operations in mind and to minimize crew interaction to process polymer film waste into usable objects via 3D printing. We've looked at the eligible trash items and selected the reclosable bags and rehydratable pouches for their ease of material extrusion additive manufacturing, as they are readily processed as thermoplastics. For our size reduction step, we considered a number of approaches to breaking down the plastic film, ultimately deciding on using paper shredder techniques and technologies to turn the film into something that we can process through an FGF printer. In order to select the end use items that we're going to print on our system, we've had the honor of interviewing retired astronaut Sonny Williams and other subject matter experts from NASA. And we were encouraged to print toilet components and small tools and structural connectors to make panels and interior dividers for a lunar habitation.
So here we have a somewhat notional representation of our full system design, including our FGF 3D printer next to our film shredding and drying machine that then transports the shredded plastic to the feed throat for 3D printing. This is our vacuum crammer subsystem, and we use a shop vac style vacuum in order to create suction at this port, and it brings the plastic film shreds in through the top, and it comes into the flights of this auger screw, which is turned by the stepper motor, and it forces the plastic film shreds into the feed throat of the FGF 3D printer.
So the LunaBotXS is going to be built off our current FGF capabilities, but we'll have a totally individualized and separate control system that will be communicated back to the actual printer. This is a mock dashboard of what kind of control we're going to have for the recycling system.
So the shredded film materials will be printed using the GigaBotX FGF 3D printer, which has demonstrated a lot of success printing useful and functional items like this. So far, our team has been printing with those films by feeding them manually into the crammer, which can obviously pose a lot of problems on lunar habitats, as it can be incredibly messy and introduce waste plastics into the environment. Therefore, over the next 4 months, our team will work on integrating the previously mentioned vacuum conveyance system and the drying system into the existing Gigabot, such that the lunar crew can minimize their contact with such messy processes. So 3D printed parts like this can be integrated with existing waste materials, which can then be turned into useful panels like this. We're looking forward to showing you more of our progress in August.